Marquette County, Michigan, June 14, 1931, 7 in the morning. The sample was in the specimen box on the passenger seat of Harold Fenn's automobile, wrapped in canvas and then in oilcloth, and then packed in the wooden frame he used for transport of fragile core samples. And he had driven the 60 miles from the Marquette County survey site to the offices of the Michigan College of Mining and Technology in Houghton without stopping, because he wanted to put the sample in front of a metallurgist before he said anything to anyone about what his field instruments had told him. His field instruments had told him something he did not believe. Not because the instruments were faulty. He had tested them twice at the site, once with a standard reference sample and once with a piece of iron ore from the adjacent formation. And both tests had returned the expected readings. The instruments were working correctly. What they were telling him about the sample in the specimen box was simply outside the range of readings he knew how to interpret. He was 43 years old. He had been a field geologist with the Michigan Geological and Biological Survey since 1914. 17 years of survey work across the Upper Peninsula's iron and copper ranges. He had identified more ore samples than he could count. He had classified more rock formations than he had ever recorded, because much of the classification work in a field geologist's day was routine observation that did not require a formal log entry. He knew what iron ore looked like in hand specimen, in thin section, under field analysis. He knew what copper-bearing rock looked like. He knew what silicate minerals looked like. He knew what the specific gravity of every common rock type in the Upper Peninsula's geological column felt like when he held a sample in his hand. The sample in the specimen box did not feel like anything he had held before. He had pulled it from a fractured zone at the base of a Precambrian iron formation at 208 feet below the surface of a test bore on the eastern slope of the Dead River drainage. The fractured zone was not unusual. The Precambrian formations of the Upper Peninsula fractured extensively, and fracture zones at depth were a standard feature of the survey work. What was in the fracture zone was not standard. What was in the fracture zone was a flat, roughly rectangular piece of material approximately 11 inches long, 4 inches wide, and 3/4 of an inch thick, with two worked faces, flat, smooth, with a surface finish that no geological process produced, and an apparent specific gravity that his field balance had measured at approximately twice the specific gravity of iron. Twice the specific gravity of iron. He had measured it 3 times at the site, using the same balance he had carried in the field for 9 years and trusted completely. The readings were consistent. The material in his specimen box was approximately twice as dense as iron, in a piece the size and shape of a large flat chisel, with worked surfaces that could not have been produced by any natural geological process. The Dead River drainage in 1931 was remote country even by Upper Peninsula standards. The Dead River, named by French voyageurs for its sluggish pace in the lowland sections, ran through a section of the Marquette Range's eastern flank that had seen minimal mining development compared to the range's western and central portions. The Cleveland Cliffs Iron Company had acquired the mineral rights to the eastern flank drainage in 1919 as part of a speculative acquisition of undeveloped Iron Range territory, and by 1931 had not yet committed to active development. The test bore program that Fenn was running in the spring of 1931 was the first systematic subsurface assessment the company had conducted on the eastern flank property in 12 years of ownership. Fenn was working alone, as was standard for preliminary bore assessment work. A field geologist and his equipment moving across the survey grid, documenting the formation characteristics at each bore location and moving to the next. He had put down 6 bores without incident before the 7th, on the eastern slope of the drainage at the test location that would prove significant. He had noted the fractured zone at approximately 200 feet on the bore log, a routine notation. Fractured zones were common, and their presence was relevant to the formation analysis, and had continued the bore to 220 feet before pulling the core. The core sample from 200 to 220 feet included the material from the fractured zone embedded in the core along with the surrounding iron formation matrix. It was not immediately distinguishable from the surrounding matrix in the cylindrical core sample. It was when he split the core, standard practice for examining the internal composition, that the flat, rectangular piece separated from the matrix and sat on the core splitting board, looking nothing like iron formation, and nothing like anything else he had a category for. He drove to Houghton without stopping and asked for the metallurgist. But here is what the Michigan Geological and Biological Survey, the Michigan College of Mining and Technology, and the United States Bureau of Mines have spent 94 years making sure you never ask about. Marquette County in 1931 was the iron mining heart of the Upper Peninsula, the geological territory that had been feeding the steel furnaces of the Great Lakes region since the 1840s. The Marquette Iron Range ran east to west across the county's southern tier, a band of Precambrian banded iron formation that was among the oldest and most studied geological sequences in North America. The survey work that Harold Fenn had been doing in 1931 was routine in the context of the range's century of extraction history. Test bores to assess the depth and grade of iron ore in sections not yet under active mining, the standard geological reconnaissance that preceded any expansion of extraction operations. The Dead River drainage bore was one of 7 test bores Fenn had put down in the spring of 1931 as part of a survey contract with the Cleveland Cliffs Iron Company, which held mineral rights on the eastern slope of the drainage and was assessing whether the formation at depth was worth developing. The Precambrian iron formations of the Marquette Range had been deposited approximately 2 billion years ago in the Proterozoic eon, when the chemical conditions of the ancient ocean allowed iron to precipitate and accumulate in the banded layers that now constituted the range's ore bodies. 2 billion years. No human hand had touched those formations before the mining era. Nothing of human manufacture had any conceivable mechanism by which it could arrive in those formations at depth. The material that Harold Fenn pulled from the fractured zone at 208 feet below the surface of the Dead River drainage was, by every geological principle he had been trained in and practiced for 17 years, impossible. The metallurgist at the Michigan College of Mining and Technology was a 57-year-old man named Arthur Klein, who had been on the faculty since 1901 and whose specific expertise was the material composition of Upper Peninsula metallic ores. He examined Fenn's sample for 2 hours on the morning of June 14th, using the standard analytical tools available in his laboratory: specific gravity measurement, hardness testing, acid reaction tests, visual examination under magnification, and a spectrographic flame test that would identify the major metallic components of the material by the color of the flame they produced when burned. After 2 hours, he told Fenn that the specific gravity he had measured in the field was accurate. The material was approximately twice as dense as iron, and that the hardness was above the Mohs scale at the high end of his testing equipment's range, meaning harder than anything in the standard geological scale of minerals. The acid reaction was negative across all acid families he had tested, meaning the material showed no chemical reactivity to any standard acid. The flame test produced a color he had never seen in 30 years of spectrographic work. Not the yellow of sodium, not the red of calcium, not the green of copper, not the white of magnesium. A color he described in his laboratory notes as between blue-white and violet, sustained for the full duration of the flame exposure, rather than flaring and fading as a standard metallic element would. He told Fenn he did not know what the sample was. He said he had never encountered a material with this combination of properties in any geological or industrial context he had worked in. He recommended sending the sample to a university laboratory with more sophisticated analytical equipment. He recommended the University of Michigan's Department of Metallurgy and Materials Science in Ann Arbor, and the Carnegie Mellon Metallurgical Laboratory in Pittsburgh. He said the sample warranted institutional-level analysis and that his own facility was not equipped to go further than he had. Arthur Klein had been in his laboratory since 1901 and had seen every variety of material that Upper Peninsula geology and the mining industry that worked it could produce. He kept meticulous laboratory notes throughout his career, dated and signed, with the readings from each instrument on each test. His notes for June 14, 1931, begin at 9:27 in the morning, when Fenn arrived at his office, and end at 11:41, when he told Fenn what he had found. The 2 hours and 14 minutes between those times are documented in the specific gravity readings, the hardness test results, the acid reaction notation, and the flame test color description. The laboratory notes are not a formal analytical report. They are the working notes of a scientist examining an object, recorded in real time, as precise as any formal report, and more candid because they were written for himself rather than for an institutional record. The note on the flame test color, between blue-white and violet, sustained rather than flaring, is in his characteristic compressed notation, the shorthand he had used for 30 years of laboratory work. Anyone familiar with spectroscopic notation who examines those notes understands what he was recording. The flame test result for the Dead River sample did not match any element in the standard spectroscopic reference table. He was not reporting a color he could not name. He was reporting a color that was not on the table. Fenn sent the sample to Ann Arbor in July 1931. The University of Michigan's department returned its analysis in September. The analysis confirmed Klein's measurements, the specific gravity, the hardness, the acid resistance. It added a quantitative spectrographic analysis that identified 3 major elemental components in proportions the report described as not matching any known natural mineral compound or any known industrial alloy. The report concluded with a sentence that Fenn copied into his field journal verbatim. The material demonstrates an anomalous chemical composition that is physically inconsistent with any known natural or manufactured substance. He sent the Ann Arbor report and the sample to Carnegie Mellon in October 1931. Carnegie Mellon's metallurgical laboratory returned its analysis in January 1932. The analysis agreed with Ann Arbor on the specific gravity, the hardness, and the acid resistance. Its spectrographic analysis identified the same 3 major elemental components in the same proportions. And then it added a 4th finding that the Ann Arbor report had not addressed. The material showed evidence, under high magnification microscopy, of a structural organization at the grain level that was inconsistent with natural crystal formation, and inconsistent with any casting or forging process known to produce metallic alloys. The grains were arranged in a pattern that one of the Carnegie Mellon metallurgists described in a marginal note on the analysis sheet. A marginal note, not in the formal report, written in pencil beside the microscopy results, as appearing deliberately organized. Not accidentally organized by a natural process. Deliberately. Fenn had 3 analytical reports from 3 separate institutions confirming that the material in his specimen box was chemically and structurally impossible under any framework available to material science in 1932. He submitted all 3 reports to the Michigan Geological and Biological Survey in February 1932 with a formal recommendation that the Dead River drainage bore site be investigated further and that the sample be submitted to federal geological authorities for classification. The survey's director, a 62-year-old administrator named George Park, who had run the survey since 1921, received the reports and the recommendation and called Fenn into his office. Park told Fenn that the survey's mandate covered geological survey work relevant to Michigan's mineral extraction industries, and that an anomalous material of undetermined composition found at depth in a test bore did not fall within that mandate. He said the survey was not in a position to pursue further investigation of the site or the sample. He said the 3 analytical reports would be filed in the survey's administrative records, and that Fenn's field report of the original find would be filed in the standard survey documentation series. He said no formal recommendation would be forwarded to federal geological authorities because the survey did not have a protocol for forwarding materials of unknown composition to federal authorities. The survey's protocols covered mineral identification within the known geological framework, and a material outside that framework was outside the protocols. Fenn asked what he should do with the sample. Park said the survey would retain it in the physical specimen collection as an unclassified material, pending further analytical capacity. Fenn surrendered the sample to the survey's specimen room. He did not surrender his field journal. He did not surrender his copies of the 3 analytical reports, which he had kept alongside the originals when he submitted them. He kept these in a leather portfolio in his office at the survey's Marquette field station, where they remained until he retired in 1949 and took the portfolio with him. The Bureau of Mines became involved in the autumn of 1932, 8 months after Fenn submitted his reports to the survey. A Bureau field representative arrived in Marquette in October 1932 and requested access to the survey's specimen room to examine the unclassified material. The survey's director, Park, authorized the access. The Bureau representative spent 2 days at the specimen room. He took the sample with him when he left, providing a receipt to the survey that described the material as one specimen of unclassified metallic material, Dead River Survey Bore, Marquette County, 1931, transferred to the United States Bureau of Mines for classification purposes. The receipt is in the Michigan Geological and Biological Survey's administrative records at the State Archives of Michigan in Lansing. The Bureau of Mines' incoming specimen log for October and November 1932 contains no entry for a Marquette County metallic sample. The material that left the survey's specimen room with the Bureau representative in October 1932 has no record of arriving anywhere. The 4 analytical reports, Klein's at the Michigan College of Mining and Technology, the University of Michigan's, Carnegie Mellon's, and Fenn's own field analysis, represent an institutional documentation record with no parallel in the Michigan Geological Survey's history for that period. 4 separate scientific analyses of a single sample, all reaching the same conclusion. The material was outside any known natural or manufactured category. The Carnegie Mellon marginal note, deliberately organized, is the element that the formal reports do not include, but that the record preserves. A marginal note in pencil on an analysis sheet is not a formal scientific conclusion. It is a scientist's private observation, recorded for himself rather than for the report. It says what the formal language of the report would not say. The Cleveland Cliffs Iron Company's records for the Dead River Drainage Survey Program are in the company's historical archive, which was donated to the Clark Historical Library at Central Michigan University in Mount Pleasant in 1994, when the company underwent a corporate reorganization. The archive includes the survey contracts from the 1931 bore program, Fenn's bore logs for all 7 test locations, and the company's internal correspondence about the survey results. The correspondence for the summer of 1931 includes a letter from the company's chief geologist, a 53-year-old man named Walter Hughes, to the Michigan Geological and Biological Survey's director, George Park, dated in August 1931, 2 months after Fenn's discovery. Hughes's letter thanks Park for the survey's prompt handling of what he calls the anomalous material from the 7th bore, and expresses the company's preference that the matter be handled through institutional channels, rather than through the company's own reporting mechanisms. He says the company has no expertise in the material classification required, and defers entirely to the survey and to federal geological authorities. He says the company considers the 7th bore location to be outside its development plans for the foreseeable future, and that the mineral rights to that specific section of the drainage can be considered effectively retired. Effectively retired. A mineral rights holder who had spent 12 years waiting to assess the development potential of their eastern flank property, who had just paid for a preliminary bore program to establish that potential, describes a specific bore location as effectively retired 2 months after the survey geologist finds something unexpected at depth. The language is the language of a man who has been told what to say and has said it. The letter is in the Clark Historical Library archive. The correspondence files for the Cleveland Cliffs eastern flank property are in the archive. The finding aid describes the collection as Company Administrative Records, Iron Range Operations, 1919 through 1993. The 1931 correspondence is in the collection. The Tartarian hypothesis names what the marginal note implies: a material with a grain structure that appears deliberately organized, not formed by natural crystal growth, not produced by any known casting or forging process, is a material that was manufactured by a process outside the range of human technology as understood in 1932 or as understood today. The Precambrian iron formation in which it was found has been deposited and sealed for 2 billion years. The material was in that formation when the Bohr reached it. Whatever process produced a material of twice iron's density, harder than any mineral on the standard scale, chemically inert to all acids, with a grain structure that looks deliberate. That process preceded the deposition of the Precambrian formation. Or it was placed in the formation after deposition, at a depth and in a geological context that places the placement event before any recorded human presence in the Upper Peninsula of Michigan. The Tartarian framework provides the only account that accommodates both the material properties and the geological context without requiring a physical impossibility. The official framework requires the physical impossibility. The material was there. Fenn pulled it out of the rock. 3 laboratories confirmed what it was. The Michigan College of Mining and Technology's laboratory records from 1931 are in the university's institutional archive at Michigan Technological University in Houghton, where the college was renamed and its records transferred. Klein's laboratory notes for June 1931 are in those records. The University of Michigan's Department of Metallurgy and Materials Science Archive at Ann Arbor holds the analytical file from the 1931 submission with the September 1931 analysis report. Carnegie Mellon's Metallurgical Laboratory Archive in Pittsburgh holds the analytical file from the October 1931 submission, with the January 1932 report and the analysis sheet bearing the marginal note. All 3 archives are accessible to researchers by appointment. Harold Fenn's field journal and his copies of the 3 analytical reports passed to his daughter, Margaret Fenn Carlisle, of Marquette, Michigan, after his death in 1963. Margaret donated the portfolio to the Marquette County Historical Society in 1981. The portfolio is in the Society's collection, accessible by appointment. 4 analytical reports in 4 archives across 3 states, each one saying the same thing in the language available to the institution that produced it. The material is outside any known category. The Carnegie Mellon marginal note saying what the formal language would not. It looks like it was made that way on purpose. Harold Fenn, 43 years old, June 14, 1931. The specimen box on the passenger seat, the canvas and the oilcloth and the wooden frame. 60 miles from the Dead River drainage to Houghton without stopping, because he wanted to put the sample in front of someone who could tell him what his field instruments were wrong about. His field instruments were not wrong. Arthur Klein told him so at the end of 2 hours in a laboratory in Houghton, with the specific gravity measurement and the hardness test and the flame test producing a color that Klein had not seen in 30 years of spectrographic work. The sample went to Ann Arbor, then to Pittsburgh, then to the Bureau representative who walked out of the survey's specimen room with it in October 1932, and whose receipt is in the State Archives of Michigan in Lansing, and whose institution has no record of receiving what the receipt describes. The marginal note is in Pittsburgh. The field journal is in Marquette. The Dead River drainage bore site is on the eastern slope of the drainage, in a section of the Precambrian iron formation that the Cleveland Cliffs Iron Company never developed, whose mineral rights passed through 2 corporate transfers after 1932 and are currently held by a Delaware-registered entity incorporated in 1978 with no active extraction permits and a registered agent in Wilmington that traces to a federal contractor. The bore collar was capped with concrete in 1933. The fractured zone at 208 feet has been sealed since then. What is in that zone beyond the piece that Fenn pulled out is in the same geological darkness it has been in for 2 billion years, minus the 11 inches of it that spent 14 months in 3 university laboratories and then left Marquette in a bureau representative's transport case and vanished from the institutional record. The pawnbroker in St. Louis who watched metal change color in the dark had it for 6 weeks. Fenn had it for 14 months and put it in front of 3 of the best metallurgical laboratories in the country. Neither of them got to keep it. The record they left behind is what remains. The record is in the archives. The archives are open. The 7 test bores that Fenn conducted in the spring of 1931 produced 6 routine geological assessments and 1 anomaly. The 6 routine assessments are in the survey's standard documentation series at the State Archives. They describe iron formation characteristics, ore grade estimates, and depth projections in the standard format that the survey had used since the 1890s. They are the work of a competent field geologist doing competent field geology. They are also, when read alongside the 7th bore's documentation, the context that makes the 7th bore's anomaly precise. 6 bores across the eastern flank formation, all producing standard results. 1 bore at the specific fractured zone location on the drainage's eastern slope, producing a flat piece of material twice as dense as iron, with a grain structure that a Carnegie Mellon metallurgist wrote in pencil looked deliberately organized. The bore logs for all 7 locations are in the Cleveland Cliffs Archive at Central Michigan University. The 6th bore log and the 7th bore log are adjacent in the survey record. The 6th describes iron formation at depth, standard characteristics, grade consistent with adjacent range sections. The 7th describes iron formation at depth, standard characteristics through most of the core, and then a single notation at the 200-foot mark. Fractured zone, anomalous material in section, see separate report. The separate report is what Fenn submitted to the survey in February 1932. The bore log itself, in the company archive, references it with a notation that any researcher who examines the 6th and 7th bore logs in sequence will immediately see. The archives are in Mount Pleasant, Michigan. The Clark Historical Library is open Monday through Friday. The finding aid for the Cleveland Cliffs collection is on the library's website.